Good morning, everyone. Am I audible?
Good morning, sir.
Okay. The screen is visible?
Yes, sir.
Yes, sir.
Okay. Thank you. Yeah. Yeah, dear student, in the yesterday class, we have discussed about the side distance. In that side distance, the first component what we have seen in the sense stopping side distance. So in continuation of that, today we are going to cover how we are estimating that stopping side distance for the different scenario. So before moving to the problem, we should know what is that equations and what are the parameters are involving to estimate the stopping side distance. So that is the way I have explained the stopping side distance, how it is defined. The driver, the vehicle driving in the car A, when he is seeing some obstacles in the point Y, he is able to apply the brake and stop the vehicle without making any accident or conflict with the object which he observed in the point Y. So that stopping side distance is considering as a safe stopping side distance, which is nothing but SSD. Okay, so that is divided into the two components. One is the lag distance and the braking distance. So the lag distance is observing, perceiving and taking the decisions, which is nothing but PIEV theory, which we have seen on the yesterday class. So once he has taken the decision, he is applying the brake. Once he started applying the brake, it is traveling in the 100 kilometer per hour. Immediately it won't stop, right? To reach the 0 kilometer per hour, it takes some time. So that time is considering as a D2 braking time. So that is the way we are defining the SST is nothing but the combinations of the two components, lag distance and the braking distance, D1 plus D2. Okay, so this D1 is nothing but the vehicle is traveling in the design speed or the vehicle speed. Okay, it might be the V or capital V depending upon the kilometer per hour or the meter per second. So during that design speed or the vehicle speed, is reacting. So the reaction is nothing but the reaction time T. So basically the reaction time is estimated as 2.5 seconds from the IRC that we are considering. So it is simple to estimate the distance D1, the speed of the vehicle into the reaction time of the vehicle. So this is the way we can estimate the value of D1 in case the design speed or the vehicle speed is given in a kilometer per hour. Yesterday we have seen these conversations, right? So we have to convert into the 0.278 into V into reaction time. So this is the way so we are doing. Okay, yesterday we have a seen. So this is an equations for estimating the D1 from the A points to his reaching point D in the speed of the vehicle. Given the speed of the vehicle during that time, what he is doing in the sense he is reacting. So that reactions can be influenced with respect to the reaction time, which is nothing but small t. So this is in a one component with respect to reaction time, lag distance. The second will be the braking time. So the braking time is nothing but depending upon the kinetic energy of that particular vehicle. So example, everybody knows that the kinetic energy is equal to half into mv squared. I'm not going much into the mechanical properties or the design elements towards that energetic formula. Just to directly applying the brake and we are planning to estimate the distance for that particular purpose. The kinetic energy of into mv squared, we know that we are applying according to our conditions. The vehicle is not a mass, it is a weight. So when we are trying to convert w divided by g into v squared, so this is in a one way we know that when we are applying the brake, it is traveling for the distance d2, right? So this is the t2 we are estimating. So that basically depending upon the weight of the vehicle, frictions between the road as well as the vehicle, and the distance what we are covering d2. So this is in a three components which is defining the braking force, which is nothing but wf. So the braking force is highly depending upon the weight, frictions, and the distance what it has been traveled after applying the brake. So this is, we are assuming it is equal to the kinetic energy. So we are trying to equate both the value. So probably w into f into d2 is equal to off into w into g into v square. So this is the things we are getting. So when we are trying to estimate the value d2, so you are getting equations v square divided by 2g into f. So this is the things, the distance d2 when the speed is considering as in a meter per second. In case if it is considering as in a kilometer per hour, you know that you have to convert it, right? 0.278 into v capital the whole square, because the square is there, divided by 2 g. Everybody knows that 9.81. So when we are applying g 9.81, you try to simplify these equations. Finally, we are getting v squared divided by 254 into f. So this is an equations for the d2. After applying the brake, the vehicle reaching the velocity from 100 to 0. For that, it has a taken distance of the d2. That d2 is ultimately depending upon the coefficients of the frictions, weight of the vehicle, also the velocity, which is indirectly getting the braking force and the kinetic energy. When trying to simplify in a simple manner, you are getting the equations d2 is equal to v squared divided by 2gf. In case if you are considering kilometer per hour, then d2 is equal to v squared divided by 254 f. So this is in a final equations, and I have already defined the SST is nothing but the two component d1 plus d2, lag distance and the braking distance. So the d2 is nothing but 0.278 into capital V into T. This is nothing but reaction time, plus V squared divided by 254 into F. So this is an equations we are considering for estimating the stopping side distance. So this is for the plain terrain. So we are not considering any terrain type. It is a plain terrain. There is a no rolling or the steep gradient 5% or the 10%. So we have not considered what we can say any gradient. Okay, in case if it is coming to the gradient, so that can be affected with respect to the frictions value. So that can be added in respect to the frictions coefficients. So in case the terrain is not on a plain terrain, you have the gradient value as an a percentage. You little bit modify these equations and apply it. So 254 f plus or minus 0.01 into gradient. I'm putting g. Don't confuse with gravity value as well as the gradient value. Okay, so this is also g. I'm just denoting. So this is in a final equations for the stopping side distance with respect to the lag distance and the braking distance in a plain terrain, in a rolling terrain, or when the gradient is given. So this is an equations with respect to the kilometer per hour. In case if it is meter per second is there, small v into t plus v square divided by 2gf. So this is an equations, slightly modifications are happening. So this is with respect to SST, the very simple estimations and the simple derivations, and you should keep in the mind what are the factors are influencing what will be the value. Also the stopping side distance, we know the reaction time 2.5 second. So problem mostly they won't give for the stopping side distance. You directly what we can say apply it in case if it is not given in the problem. As per the IRC standard, the reaction time for the stopping side distance is 2.5 second. Accordingly you can apply it. So this is with respect to the stopping side distance. Very quickly we can cover simple problems in the stopping side distance. So the first problem related to the stopping side distance is determine the stopping side distance SST on a two-lane highway with a two-way traffic. Okay, so two-lane highway is a two-way traffic is there is a no median. Then what they have given, the design speed of the highway is given as a 65 km per hour. Assume a coefficients of the frictions of 0.3 they have a given, and the total reaction time is 2.5 seconds. Again it is given. If it is not given, you have to assume the maximum coefficients value of 0.35 and t as in a 2.5 second. What will be the side distance if two-way traffic is permitted on this highway for a single lane? So this is the things they have a given. Okay, stopping side distance they were given, and they were so they given the parameters and they were asking the stopping side distance for the single lane, okay, for the two-way traffic, which means that there is a no median. That yesterday itself I have told that if it is given as an with respect to that without median, whatever the stopping side distance you are estimating, that has to be multiplied by 2. If you remember that I told that 80 second is then SST, then you have to apply twice than 80. So this is the way the final equation, final estimations you have to calculate it. So as you know that the SST equations, just we have a derived, the equation is nothing but 0.278 into V into reaction time plus V square divided by 254 into F. There is no gradient, that's what I stopped with F. So in the equations, what are the parameters are required? Speed. The speed is given as an 65. It is in the kilometer per hour. So directly we can apply it. So this equations for the kilometer per hour. In case if it is given as a meter per second, the equation is changing. The previously it is changing, right? So according to that you have to modify it. Then what are the other parameters required? Reaction time. That is nothing but 2.5 second. Then the coefficients of the frictions value is nothing but 0.36. So this is a value we have get it from the given problem, and directly when you are trying to apply in that equations, SST is equal to 0.278 into V is nothing but 65 into 2.5 second plus what is it value 65 square divided by 254 into 0.36. Okay, so estimate the value. What is the value you are getting for the SST?
91.38.
91.38.
38.
Okay, 91.38. It's a distance, so you are getting in the meter. So even though if you're applying, you come to know, okay, kilometer per hour. So then the meter, okay, time is in the second. So when the conversations are happening, you come to know the distance in the meter. So the SST value you are getting as in a meter, and when it is coming to the single lane, as I told that the traffic is allowed without median. So the stopping side distance is not defined with respect to what we have estimated. So it is considering the opposite directions flow also. So that is the reasons we are multiplying the value 2 into 91.38. Probably you might be getting 180 plus 182 or 83 you might be getting. So 183 meter. So you estimate your the exact value using the calculator. So this is the simple way we can estimate the stopping side distance. Definitely we can expect the questions from the stopping side distance, but the only complexity happen with respect to the units and which type of the equations you are applying and getting as a final output. So that trick you have to take more care by reading that questions what it is given. According to that you can estimate it. So this is in a one first problem, the direct estimations. So the solution is given over here the same. The next, the same. For the conditions of the same problem, the first problem, you assume the first problem, this SST, they are asking if the ascending gradients of 3%, ascending in the sense increasing, right? Plus 3% it is increasing. That gradient, when you are trying to consider what will be the SST value. Simple, the same equations, F plus this 3 if you are applying 0.01 into 3 if you are applying, so you might be getting some value, right? So accordingly the equation is modified. So let me explain the equations once again. Stopping side distance is equal to 0.278 into V into reaction time plus speed of the vehicle 254 friction plus or minus 0.01 gradient. So speed is given as a 65, T is nothing but 2.5, F is they have a given as a 0.36, G it is an ascending positive gradient, so 3 we are considering. So when we are applying all the value, you will get what will be the value 0.278 into 65 into 2.5. So this is nothing but your lag distance. Maybe the question also just to look at what is the lag distance, whether the question is asked lag distance only or the braking distance or the total stopping side distance, like way they may ask the question also. So 65, 254, 0.36 plus 0.01 into 3. So you might be getting what will be the stopping side distance when we are trying to consider the ascending gradient of 3% for the same data given for the previous problem.
87.82.
How much? 87, 87.83.
83.
Okay. So this is in a stopping side distance. You just to check it whether the ascending or the descending gradient they have a given. According to that, you have to consider plus or the minus. Then you are applying in the simple equations. You will be getting the what will be the stopping side distance. So here in this problem, they told that here I'm just telling that you have to take the value from that first problem. So we have not specified with respect to the lane discipline or the lane. So that's what I'm just stopping here. In case if it is mentioning the same things, then you try to apply the equations twice that SST value and estimate it. So probably you might be getting what we can see 190 plus, okay, 170. So this is with respect to the second problem. It's a straightforward problem, but don't expect the straight problems always. It will be there some hidden trick. Obviously, they will be asking when it is coming to the competitive exams. So that definitely can be estimated. Maybe the next problem you can see, you just understand. So the third problem also it is connected to that SST only. Determine the safe stopping distance to avoid head-on collisions of two cars approaching at the speed of 80 km per hour and 65 km per hour. So you consider the one road, okay? So one vehicle A is traveling, that opposite vehicle B is traveling, and the A is traveling in the 80 km per hour and the B is 65 km per hour. At certain point, they are observing each other. There is a probability to make the head-on collision. To avoid that head-on collisions, what will be the stopping side distance? What is the distance, safe stopping side distance between the vehicle A and B? That we have to estimate with respect to the speed of the vehicle A and the speed of the vehicle B. So basically you have to estimate two SST. One is with respect to the vehicle A, SST for the A vehicle, SST for the vehicle B. When we are trying to add both the value, then total safe stopping side distance you are getting. So this is the explanations of that particular problem. Other than that, they have assumed the reaction time as in a 2.5 second. Coefficients of the frictions they have a given 0.36, but the braking efficiency they given us as 75% for the both cars, which means that the frictions I told now, the friction is between the vehicle and the vehicle tire and the surface of the pavement, right? The frictions are happening. So every time during the calculations, what we assume that the vehicle is we are getting 100% efficiency. Okay, our vehicle is perfect. So when you are applying the brake 100% efficiency, we are getting that 100% efficiency. What is the standard coefficients friction in the sun? 0.36. So this is an assumptions we made it when estimating the coefficients of the friction. But in the brake efficiency of this particular problem of the both car is not 100%. It is reduced to 75%. So when it is reduced to the 75%, they are not achieving the 0.36 coefficients of the frictions on the field. The reductions happen. So that reductions we have to estimate it. So F is equal to, they are not getting 100%. They are getting 0.75% only. They are 75. That means 75% only they are achieving from the given coefficients of the friction. So when you are applying, you come to know what will be the actual coefficients of the friction for the vehicle A as well as the vehicle B. So this is in a one way they can trick you. So the braking efficiency, it is not 100% for the both vehicle. So it has an only 75%, and the standard coefficients frictions they have a given 0.36. It has to reduce with respect to the 75%. Then the total value 0.75 into 0.36. What is the value you are getting?
0.27.
0.27. So this is in a coefficients of friction. Then the remaining everything is same like the previous only. You have to estimate for the car 1. So maybe the car A, you have to estimate the SST value. SST is equal to, there is a no gradient, so directly you can apply it 0.27 into speed of the vehicle is 80. Reaction time is given as a 2.5 second. So this is a lag distance. Then the braking distance V squared, 80 squared divided by 254 into, you have to apply this coefficients of the friction, not 0.36. So you have to apply 0.27. So you come to know what is this stopping side distance for the vehicle A. At the same time, estimate the value for the car B. SST bar car B. You just change that speed 0.278 into 65. Same, the reaction time is 2.5 second plus, sorry, it's not it's 65. Okay, 65 square divided by 254 into 0.27. When we are applying, you will get the stopping side distance for the vehicle B. For the safe stopping side distance for the both vehicle, you have to add both stopping side distance for the vehicle A plus stopping side distance for the vehicle B. And what is the total? That is the stopping side distance. What is the value you are getting for the vehicle A?
160.95.
160.95.
60.95.
Stopping side distance for vehicle B?
160.95, sir.
Vehicle B. Okay, estimate for the vehicle B.
No, 106.78.
So when you're trying to add both value together, so you might be getting what will be the total stopping side distance. 160 260, 266, approximately 267 or 278 it is coming, maybe 278 we can assume it. So this is a stopping side distance between the vehicle A and B. If you want to avoid the head-on collisions when you have the braking efficiency of the 75% of the both cars. Most of the time the floated problems I given the reaction time and the coefficients of the frictions. If it is not given, you assume this IRC standard value for that particular problem. So this is with respect to the stopping side distance. Is there any doubt from the student side for the stopping side distance? It is simple, but sometimes you may get confused with respect to the given unit, so that you have to uh, take more care by reading the questions once or twice. Okay, if there is a no doubt, I will move to the next component of the side distance, which is nothing but overtaking side distance. So basically, that requirement of the overtaking side distance are happening in the sense when you are traveling on the road. Okay, the design speed is 80 km per hour. All the vehicles are traveling on the road by given design speed, which is nothing but 80 km per hour. Then there is no need to introduce that or the study about overtaking behavior or the overtaking side distance. But in the field it is not true, right? It is not applicable for the all the cases. The different kind of the vehicles are there, and their requirement are different, their loading capacities are different, the driver behavior also differ. We are free to choose any speed when we are traveling on that particular road. So there is no need to follow only the 80 kilometer. 80 kilometer is a design speed. Maybe you assume that that will be the maximum speed, just an assumption I'm telling. But all the vehicles are not traveling in the 80 kilometer. So the small truck or heavy load, the buses, it might be moving slightly slow. So the slower vehicles are moving on a slow speed. The same corridor, at the same time, the fast moving vehicle, you might be driving a two-wheeler in the 80 kilometer or the 100 kilometer, or the car, personal car you are traveling. So that thing is considering as a fast moving vehicle. So in a given road, the slowing vehicle are moving on, along with that the fast vehicle are moving on. At certain point, the fast moving vehicle needs, or it has to overtake the slow moving vehicle to maintain his journey in that design speed. So in that particular point of time, what are the conflict used to happen in the sense, if you are accepting uh, very small distance, then there is a high probability of rear end collisions with a slow moving vehicle, or the side swipe, just overtaking and immediately you are taking a left, then the side swipe might be happening. In case there is a no median, opposite vehicles are coming. If you are not getting a sufficient space, then there is a high probability to hit your vehicle with respect to the opposite vehicle while you overtake the slow moving vehicle. So these are the issues, problems are practically happening, that might be leads to some of the infrastructural damages, environmental impact, cost related negative impact, accident cost. Okay, these kind of the things are happening, but we are not going towards that particular directions. We just come to that design oriented. So to avoid those kind of the situations, we have to provide the proper overtaking side distance for the driver. It basically depending upon the speed of the vehicle. Okay, once you are planning to overtake the vehicle, what are the vehicles are involving? One is the overtaking vehicle, which is nothing but us or the fast moving vehicle. Second is nothing but the overtaken vehicle, that is nothing but the slower vehicle who is traveling in front of us. Third will be the opposite vehicle. So there is a no median, two-way traffic we are allowing, then the opposite directions the vehicle is coming, so the speed of the opposite vehicle also considered. So this is in a three parameters: the speed of the overtaking vehicle, overtaken vehicle, then the opposite vehicles. The speed is first of all affecting the overtaking side distance. The second will be the distance. So the minimum distance between the overtaking vehicle and the overtaken vehicle. If you assume that you are driving in a car, in front of you, one small truck is moving on. So what is the distance between your car as well as that truck? That distances need to be considered as an important parameter. Third, the important will be the skill and the reaction time of the driver. This is very clear term, right? The beginner, how he is that afraid to overtake, and as an 10 years experienced driver or the 25 years experienced driver, how he has a skill to take the overtaking. So definitely that is influencing the overtaking side distance. Then the vehicle accelerations, overtaking vehicle, your car, the fast moving vehicle, how the ability having with respect to the accelerations, because you are following the slow moving vehicle is going by 60 kilometer per hour, your vehicle is also slowly moving 60 kilometer per hour. Some point you taken the decisions and you have to rise your vehicle 60 to 80 or the 100, then only you can able to overtake it, right? So in that accelerations of overtaking vehicles is influencing. Finally, which is relevant to the road, the gradient, if there is a up gradient or the lower gradient if it is there, so that gradient is ultimately affecting the behavior of that overtaking distance. So these are the factors which is influencing, and that overtaking side distance is nothing but when you are planning to overtake the slower vehicle without making any conflict with the overtaken vehicle or the opposite vehicle, how much safely you are completing your overtaking behavior, that distance is considering as an overtaking side distance. So let me explain so how to estimate that overtaking side distance. So I will try to draw the road stretch. So it might not be perfect, but still you try to understand it as a stretch, straight stretch. Okay, the vehicle allowed for the two-way traffic. Okay, the first point, what happened? A little bit straight. The vehicle A is considering as a fast moving vehicle, and okay, the vehicle B is considering as a slow moving vehicle. At the same time, here the vehicle C is coming as an opposite direction. So the vehicle A1 is following the vehicle B. Okay, at some point, maybe you can consider as an this particular point. Okay, so maybe this will be the A1 point. At point A2, the driver in the vehicle A decided and taken the decisions to overtake this slow moving vehicle. Okay, so maybe this is the lane marking. So he has decided to overtake the vehicle and he is overtaking. So overtaking the slow moving vehicle by changing the lane. Okay, then again he is approaching his normal regular lane and he is reaching that ending point. So this might be considered as an A3. So this is in a behavior of the overtaking vehicle how he is reached into his new positions after overtaking the vehicle B. Till taking the decisions of the vehicle driver A, the positions of the B's we can assume that B1. Once he taken the overtaking, the vehicle is reached as a new positions in point B2. So this is in a positions with respect to the B, okay, vehicle B, while he's taken the decisions till the decisions where he is there. Once he started overtaking and ending his overtaking behavior, and the vehicle is B reached the point B2. When all this process are happening, the vehicle C is traveling as in a point C1 and it reached the point C2, which is nothing but equivalent to the vehicle, or we can say A. So this is a travel happened between the opposite vehicle. So this is a complete overtaking behavior. Definitely you might be getting, you just imagine that you are traveling on the road in the car A, the slow moving vehicle is moving, you are following the slow moving vehicle for the some distance and you've taken the decisions, then you have overtaken the vehicle and reaching the new position. When you reach the new positions, by the time the vehicle B moved from the B1 to the B2, sometimes there is an opposite vehicle is coming in the sense it reached from the C1 to the C2. If there is a no median, then no need to consider about the vehicle C. If there is a no median, you must consider, okay, the median is playing the major role for the considering the vehicle C, which is nothing but opposite vehicle. Okay, so the overtaking side distance basically we are defining with respect to the three distance between the A1 to A2 is considering as an D1, distance 1, plus it is reaching the new positions, right? So this is considering as an D2. At the same time, the opposite vehicle, how much it is journey made it, that is considering as an D3. So when you are adding all the distance together, you will get overall overtaking stopping side distance D1 plus D2 plus D3. Okay, so this D1 is nothing but, as I mentioned, that from the A1 to A2, the driver is simply following the vehicle B. So the speed of the vehicle A is nothing but the speed of vehicle B, because you are traveling in the slower speed. So slow speed you are traveling by following this particular vehicle and reaching at this particular point. So this is nothing but the direct equations which we all know, that VB into D. So the speed of the vehicle B into reaction time till the decisions what he has taken, right? That reaction time is considering as an one more parameter. So in OSD, the IRCs recommended the reaction time is 2 seconds, not 2.5 seconds. He has to react very quickly because you have to overtake it. You have to overtake the slower vehicle. You have to consider the opposite vehicle also. So the reaction time is ultimately reduced. Okay. So in that particular case, the IRCs assume 2 seconds as a reaction time. So this is an equations for estimating the distance D1. That means the car A traveled between the A1 to A2, where he has taken the decisions of overtaking the vehicle B. Okay. Then what happened in the sense, this vehicle A2 to A3 it is reaching. So the total traveling time is assumed or the considered as a capital T. This is the time taken the vehicle to reach from A2 to A3. So the total reaction time has been taken. Here, what the simple assumptions they made it for the understanding. So this distance is considering as an what we can say yes. So the spacing is considering as an yes, and this distance is considering as an B. Okay, the base spacing between the A2 and B1 and B2 and A3 before overtaking and after taken the overtaking. So it is considering as an same distance, which is denoted as an S, Okay, and the distance between the B1, B2, how much it will travel in the sense it is considering as an B. So that is a way we can define the value of D2 is equal to S plus B plus S is equal to 2S plus B. Yes, I'll check it once. Yes, so yes, S plus B plus S, 2S plus B. So this is a distance for the D2. So they have estimated. So what is the value for the S, B, that we will see it once again. But before that, if there is a opposite vehicle, so what it is happening in the sense, it is traveling in the design speed and it travel for the D time. Okay, for the overtaken starting to the ending, so that time only it is taken from the C1 to C2, so that is considering as an estimations value for this particular D3. So D3 is nothing but V into T. So T3 is equal to design speed of the vehicle into time it is taken from A2 to A3. So what is the value? So that is considering as an D3. So this is in a way when you are trying to add all the value, you will get the total overtaking side distance. So here the little bit explanations I will give with respect to the estimations of the S and B. So basically directly I'm just telling the yes we have to calculate with respect to the 0.7 into speed of the vehicle plus 6. So this is an equations. I'm not going to the definition derivations of this particular equations, but directly you taken this value for the S 0.7 into speed of the vehicle plus 6, so that distance can be estimated. Then the B is nothing but the distance only we are estimating, the speed of the vehicle and the travel time T, how much it is travel. So accordingly, so the value B is estimated. So when we are applying all this value, so you come to know what is the value for the D2. But what is the T? What is the T that we have to estimate it? So that who we are estimating in the sense the D2 is we are equating, you might be knowing the equations ut plus half into at squared. So slightly might be familiar. So this we are trying to equate with respect to the S plus B plus S. So here the U is nothing but instead of the velocity, the speed of the vehicle we are B vehicle we are considering. So this is in a total travel time plus half into A we are considering the speed of the vehicle into T squared is equal to 2S plus the B is, you know that VB into T, VB into T. So VB into T, VB into T, it will get cancelled. From this equations, when you are trying to simplify it, you will get the T value as an 4S divided by A. Okay, so this is an equations for the T value. So T you have to estimate 4 into S divided by A. So the spacing mostly they will be giving in the equations, accelerations also they will be in the giving equations, else we have that IRC standard. So according to that we can estimate what will be the value. Okay, so this is in a one with respect to that SST for the calculating the D2 value. So I think D1 and D3 is simple and the straightforward. D2 is ultimately depending upon the space and the distance traveled by the vehicle B. So that can be estimated with respect to the time T and that equations yes. So this is an equations. Okay. So finally, what are the parameters we have estimated? D1 is nothing but VB into T. T is nothing but the reaction time 2 seconds plus 2S plus B. This is your D2. In that, S is nothing but 0.7 into VB plus 6. So when you are applying the speed of the vehicle B in this equations, you will get the S value. then directly you can apply that yes here. That same yes you can apply in this particular equations spacing accelerations when you are applying, then you will get the value for the t. Okay, then the b is nothing but vb into t, speed of the vehicle b. T you have estimated using this equation when you are trying to apply it, so you will get the value for the vb. So this equation is slightly we can modify it accordingly. 2 into 0.7 into vb plus 6 plus vb into t. So this t is 4 into s divided by a root square. If you are putting, you will get that value. That s is nothing but this value is nothing but s. So if you are applying s and a, you will get the t value. So this is with respect to the D2. Finally, design speed into T. The T what we have estimated root 4 is divided by A when you are applying. So that is considering as an D3. So this is an equations for estimating the overtaking side distance. So hope you might be getting it. Is very simple. The logic is very simple. The vehicle is planned to overtake the slower vehicle B. At the same time, the opposite vehicle is traveling. So when the positions A1 to A2 it is changing, it is considering as a D1. That is depending upon the speed of the vehicle B and the reaction time 2 seconds. When you are applying, you will get the T1. At the same time, the vehicle A2 to A3 it is travel for the time capital T. For that, simply we have a divided. We consider the positions of the B1 to the B2, that is considering as a B. Then the spacing is the equal spacing before and the after. So the equations is 2s plus b. The s is calculated using the 0.7 vb into 6, speed of the vehicle b into 6. Once you estimated the s value, you know the b can be estimated as a speed of the vehicle into the travel time. That travel time is estimated using the equations root of 4s divided by a. S is estimated from here. A is based on the IRC standard. It might be given in the problem, or you have to take in the value from that IRC. When you're trying to apply it, you come to know the T value. So if you're applying the T value and multiplying by the speed of the vehicle, you will get the B value. Then S value, you know, when you're applying two values over here, you get the distance of the T2. Then the D3 is nothing but the C vehicle traveling from C1 to C2 for the time taken T and the design speed V, you will get the value directly. So this is an overall overtaking side distance estimations. So here some assumptions we have to make it. Basically, they will be giving the overtaken vehicle speed of the overtaken vehicle. In case the speed of the overtaken vehicle is not given, what you have to do in the sense, you have to example 80 km per hour. 80 km per hour they have a given as a design speed, but they have not given the speed of the vehicle VB. Okay, so what you have to do in the sense, you have to take the value of the VB is equal to design speed minus 16. So this is an equations you have to take it. So 80 minus divided by 16 if you are putting, you come to know the speed of the vehicle B. This is for the kilometer per hour. In case if it is in the meter per second, then you take the design speed what it is given in the meter per second minus 4.5. So then you get the value of the overtaken vehicle, which is nothing but the slower moving of the vehicle. So this is one assumptions, or the unit may get conflict or make confusions while you are estimating the overtaking stopping side distance. At the same time, the IRC is given with respect to the speed of the vehicle and the accelerations value. So kilometer per hour and the meter per second square. So those things they have a given. Maybe I will float here, else I will give in the PPT also. So 25 km per hour if the vehicle is traveling, then you have to assume 1.41. If it is 30, then the value is 1.30. If it is 40, 1.24. If it is 50, then the value is 1.11. 65, 0.92. 80, 0.72, and the finally 100, it is 0.53. So this is a value for the accelerations. Probably they will be giving in the problem. If it is not given, so you should know the values. Mostly the design speed will be the 80 or the 100 or the 65 out of this value expected, most probably. So just keep all the values in your mind in the competitive exam. If it is not given, you have to take value from here. If the design speed 80 is given, you have to choose the A value as a 0.72. So this is the things with respect to the accelerations. If the speed of the overtaken vehicle is not given, so how you have to take it. So V minus 16. Okay, so according to that, you have to calculate it. So this is an overview about that overtaking, stopping, distance, which is coming under the side distance chapter of your second unit. So the simple and understandable problem we will be covering from the next classes. Any doubt from the today's session? So why we have to multiply by 2 stopping side distance? I assume that you are asking in this SST value. So SST value, why we are multiplying in the sense safe stopping side distance when we are considering the without median. So in case if there is a no median, whatever the equations, the definitions, the derivations we have explained, then it is directly applicable. But when the opposite direction is coming, like overtaking side distance we have a consider, right? When the opposite vehicle is trying to approach it, then there is a probability with respect to the single lane. They have a given as a single lane, they have a given. So that case, you have to multiply by the twice. In the single lane, when it is coming to the stopping side distance, so you have to multiply by 2. So that is the reasons I have explained. You have to multiply. So see the problems and you just apply by 2. Single lane for the two-way traffic.
Thank you, sir.
Thank you, sir. Okay, so if there is no other doubts, we will end the sessions here. Monday we will see the problems, how to solve for the overtaking side distance. Then we try to move to the other side distance. So thank you everyone. Stay safe. Take care. See you next week. Bye.
Thank you, sir.
Thank you, sir.